All right, so we're finishing up this unit, and we've been talking about the digestive system. Where we left off yesterday, we were looking at the biomolecules and saying that we took them from being polymers, and we had to catabolize them, which means to do what? Break them down into a monomer form before they could be absorbed. What this is saying here is, what this section is going to talk about is how we use the nutrients, and if we don't use them, whether or not we store them. Okay? So, there are two phases we consider. Basically the differences. So it's absorptive and post-absorptive. Absorptive says, I just ate. So if I just ate, I have food and I have energy. Post-absorptive says that my GI tract is pretty much empty, so I'm starting to get hungry, or I haven't eaten in a while, so I don't have the energy that I need. Okay? And it kind of describes that right here. Absorptive is when you're ingesting nutrients and you have food within your gastrointestinal tract. Post-absorptive is when your GI tract, and GI again is gastrointestinal, is empty of nutrients. So in order for you to get energy, it has to pull from things that you've stored. Okay, so absorptive is when you're eating. Post-absorptive may be in between meals, or if you're fasting, it's post-absorptive as well. Okay? This is showing you, reiterating what we discussed yesterday. So one more time. Glucose is what type of biomolecule? Carbohydrate. So glucose is the monomer form of that carbohydrate. It is absorbed into the blood directly, and what we don't use we'll store as glycogen. We'll get there today. Triglycerides, where do they go? The lymphatic system. Remember, fats do not go directly into our blood. It even says right here, triglycerides, which are lipids, via lacteals. Lacteals are those small extensions that are within each of the villi in the small intestine, and that's where fats get absorbed. And then they go from there into our blood, and then the excess fats will be stored as adipose tissue. What's an amino acid? Proteins. Amino acids also get absorbed directly into your blood. What you don't use immediately, you're going to use to build muscle. Okay? So protein. So what we kind of went through yesterday. Now, this reiterates, and then it tells us what we do if we don't use it. So, carbohydrates on this slide alone. Carbohydrates are only absorbed when they're in their monomer form. There are three monomers for carbohydrates: glucose, galactose, and fructose. What do we use sugar for? Energy. So this first part is saying the very first thing we use sugar for is energy. When you eat food and it has glucose in it, it gives you energy. That's the whole purpose for carbohydrates. The function for carbohydrates is energy. Alright? We use that glucose to synthesize ATP. What's ATP? Energy. Yeah. Do the same chart. Way to go. Alright? There are two systems that require energy, require glucose in order to operate. The first of those is the skeletal musculosystem, or musculoskeletal system, so your skeletal muscles, the muscles on your bone. These require high levels of ATP. In order to have high levels of ATP, you have to have high levels of glucose. If your glucose levels are low, how do your muscles feel? Tired. Okay? Then you eat, glucose levels increase, and you don't feel tired anymore. There is one other system that is not listed here, but will be in just a few slides, that has to have glucose to function. Without it, what system has to have glucose? And if your glucose levels get too low, you'll faint. What system? Nervous system. Your brain has to have glucose. If you go a long time without eating, you'll get a headache first, and then if it gets too far gone, you'll faint. When you faint, that is your body saying, I am warning you. your blood glucose levels are low. If you faint because your glucose levels are low, when they wake you up, what are they giving you? Like what kind of food?
Sugar.
They're giving you like apple juice, chocolate bar, something that has glucose right then. Yeah. What? Does that make sense to you, Logan? No? No?
Just a blank stare.
Okay, sometimes it does, sometimes it doesn't. Okay, so anyways, we use glucose for energy. Now, many of us eat more glucose than we need at that immediate time. So our body stores it. There's a molecule in our body called glycogen. All glycogen is the extra glucose stuck all together, and it forms a glycogen. We put that glycogen molecule in our liver, and it hangs out there until we need it. So all the extra glucose you consume is taken up, formed into a glycogen molecule, and put in your liver. Whenever your blood sugar levels, thank you, get low, your body tells your liver, hey, I need sugar. The liver pulls that glycogen out, breaks it down, and releases that sugar into your blood. Okay? So it goes, when we eat food, specifically carbohydrates, we use our glucose first. What we don't use will store as glycogen. Now what happens if our liver is full of glycogen? Where does that extra carbohydrate, where do they go now? Fat. It goes blood, liver, then fat. Okay? Blood, liver, then fat. As far as how carbohydrates are stored, are used and then stored. Triglycerides. Triglycerides are which biomolecule? Lipids we already know, and that's what this first part says here. That they don't go directly into the blood, they go to the lymphatic system first and get filtered up, and then they get dumped back into the blood. So eventually they do make it back into the blood. The best thing about triglycerides, or about lipids, is they can also be used for energy. So we'll use them for energy. We'll also use them for insulation, for protection. So they have a lot of different functions, but their first function is long-term energy. So when you run out of glucose, guess what your body asks to do the work next? Fats. Okay? And I mentioned this before, but a lot of times you have people who say, ooh, I'm going to go work out and burn some fat. If you go work out, you're going to burn your glucose first. It's going to take you about 30 minutes to get through your carb supply before you get to your lipid supply. So making sure that if your goal is to use your fats for energy, so to burn fat, you have to do more than just 20 to 30 minutes of physical activity. You're going to have to do a little bit more. Okay? Also, the only reason you would gain weight is you're taking on more than you're actually burning. So if you take in 2,000 calories and you burn 2,000 calories, you should stay the same size. But if you take in 2,000 calories but you only burn 1,200, you're in excess of 800. So it starts to store that. It's like people think that this eating thing and all this weight, it's not like a big math science type thing. Like you use it, you eat it, you use it. You eat it, you use it. If you eat it and you don't use it, you store it. Okay? So
No, certain diets and stuff, they don't, like fat-heavy diets, like keto diet and stuff. How's that work?
well, actually,
You don't have sugar to
exactly. I was just about to go into that. We call it gluconeogenesis, which is meaning it's going to take something that's not carbohydrate, which would be a lipid, and it turns that into glucose. It requires far more energy for your body to do that, so you burn more calories. You get more energy from fats, so it makes sense. But the thing is that a lot of people consume far more. It's again, they like think, okay, well I can eat a whole 3 pounds of bacon. It's not 2 pounds. Like it's never mind. Sorry. If you eat 3 pounds of bacon. It's not good for your heart too. Okay. Great question. So I call them fad diets, like the keto diet, all that. If you truly starve your body of these nutrients that they need, eventually you're going to see deficiencies. When you increase your fat intake, where your cholesterol is really high, guess what we see in your blood long term? Fats that don't need to be in there. We call them HDLs and LDLs. The low density lipoproteins, we don't want those. And we start to see those. So it does help you short term. But if you want a long-term difference, it's a lifestyle. You have to just teach yourself how to eat right. And some of you are comfortable, and you'll be comfortable in your life, and you're like, oh, it doesn't really matter. And then you're going to be like, oh, I can never lose weight. You can if you create a deficit. But you have to do that. And a lot of people are like, oh, it's just killing me not to eat. And I get it, because it's a psychological thing. But going on certain diets to just restrict what you eat, in the long run, you're going to see deficiencies. In the long run. In the short term, you're going to see the weight loss you want. Then a lot of times what we see is when people get that weight loss, they reach their goal, they lose 10 pounds, then they stop, and guess what happens? They bring back 12. And that's exactly why it's called yo-yo dieting. Because you'll lose it, and then you'll come back with more. It's a lifestyle. Like, if you want to live a healthy life, it's a choice every single day. It can't just be like that. Hey, I'm going to do this diet for Lent and lose this weight. That's not a thing. Did that answer your question? Mm-hmm. Of course. Oh, and I didn't speak about this. Okay, so amino acids are when we take proteins in, of course. We break them down to amino acids and we absorb them. What are we going to do with amino acids? What are we going to do with amino acids? We're going to make proteins. That's what you use amino acids for. You use them to make proteins. So we take in protein, we catabolize it to amino acids, then we use those amino acids to make proteins for us. And that's what it says here. What if you take on too much protein? It says, we'll use it and store it as fat. It is very difficult for you to take on more protein than you actually need. Okay? People say, well, I'm on a high protein diet. Am I going to get fat? No. It's numbers. Like, if you're going to eat 1,000 grams of protein and your goal is to bulk up, this is what you do, like a math type thing. Like, it's simple. If you're trying to get bigger, you eat more than you're going to eat. If you're trying to get smaller, or eat more than you're going to use. If you're trying to get smaller, you eat less than what you're going to use. Or if you want to maintain what it is you're eating, you increase your activity level. Most people can maintain their weight with absolutely no outside exercise other than what they normally do on a regular basis, like walking up the stairs or working on this or picking up this box. They do it just by eating. You will lose weight and maintain a healthy lifestyle long term by eating. You don't necessarily have to work out and lift weights and run and do all that crazy stuff. Yes?
Another random question. Do you actually burn calories if you just sit out in the sun and stuff like that? Like, how you feel tired after you just sat out in the sun?
So sitting out in the sun dehydrates you, number one. Number two, you're constantly burning calories. So you could lay in bed all day and you're still burning calories. But here's the problem, is you're probably consuming more calories than you're burning. So when you lay in bed and eat Doritos all day, oh, from the back row of the church, amen, Doritos. You're not burning that whole bag of Doritos. And I'm sure it's not the snack bag. No, yeah.
It's the party size.
Yeah, family size. Like, yeah. Oh. Yeah, it's no surprise, no surprise. All right. During the post-absorptive period. So at this point, you're done eating and your GI tract is pretty much empty, so you're sending messages to your brain saying what? It's time to eat, not... Logan. Yeah, it's whatever. Just never mind. Anyways, you're sending messages to your brain saying it's time for me to eat. Your blood sugar levels are going down. So you're starting to feel what? Tired. This is you, if you eat lunch around noon, this is you around 2:30. You start to kind of hit that afternoon like, Literally, your sugar levels have dropped, so it's making you tired. You're feeling, your body, if you don't eat then, and that's another thing, it's just because you're tired doesn't mean you're hungry. So a lot of people mix that up. But anyway, that's a different lecture. Your body will, because their blood glucose levels are low, it will tell the liver, hey, I need some glycogen. And the liver will release glycogen, break it down, and then allow that glucose to go throughout your body. So if you just give yourself a little bit of time and get up and move, your blood glucose levels will go back up, okay, because you have stores of that. So blood glucose has to maintain a homeostatic level. Specifically, it says here, for the CNS. The CNS is an abbreviation for the central nervous system, which is your brain and spinal cord that I mentioned just a moment ago. So your muscles and your brain need that glucose in order to continue their function effectively. Okay? Now, let's say that, I'm going to go to the slide after this and then I'll come back. Let's say that you're not going to eat, your glucose levels are getting low, blood glucose levels are low, you're not going to eat. Two things can happen. The first, glycogenolysis. Glycogenolysis. What? Dissect that word. Tell me what it is. So here's glycogen, here's lysis, so I'm just breaking down glycogen. Do you remember what glycogen is? It's a bunch of glucose molecules that we pack together and put in our liver. So our blood glucose levels go low. The first thing that happens is we tell our liver we need to break down glycogen. So it will pull a glycogen molecule out, break it down, and disseminate that glucose throughout our body. Glycogenolysis is taking glycogen from our liver and breaking it down and releasing that glucose into our blood. Now what if that's not happening? What if there's no glycogen or low glycogen? So it's been a long time since you've eaten, okay? You may be fasting or something like that. Your body then goes through what we call gluconeogenesis. Dissect this word. What's gluco? Sugar. Okay, what about neo? New. Genesis. Creation of. The creation of new sugars. From things that are not sugar. Your body, if you don't have enough carbohydrates, will say, let me have some of those lipids, and I'll turn those lipids into energy, which is what you're talking about here on these low carbs, no carb diets, where you're taking in a lot of lipids. You're asking your body to do more work. It does burn more calories, so you do see a difference, but it's a deficit in calories that you need to see. You need to be consuming less than what you're burning. So gluconeogenesis is turning fats into glucose or proteins into glucose. Proteins into glucose is a scary thought, though, too. By the time you've burned through all your fats and now you're burning protein, you're basically catabolizing muscle. That means that you're probably pretty malnourished. It's been a while since you've eaten. Okay? So that could be an issue, just so you know. So your goal would be first carbohydrates, then lipids. If you're burning proteins, that's a sign that your body is not very healthy, or has been is fasting for so long that you're not feeling very well. Okay. Oh, I need to go back to that picture to make sure I explain. Sorry. Here it tells you glycogenolysis. Glycogen is broken down from the liver into glucose and released in the blood. And then gluconeogenesis is taking things that are not carbohydrate-based, so triglycerides and proteins, and turning them into glucose. So that's what this diagram is showing. And we're doing that to increase our blood glucose levels. Okay? Now, on insulin, let me show you the picture of insulin first. And again, this is not digestion. We're specifically talking about what happens after. If you are not diabetic, then this is you. When there is sugar outside of your cells, there's two places that sugar can be in your body. Your blood, so we call it blood sugar, and then in your cells. So here's my cell. Outside of it would be my blood. So blood sugar or intracellular sugar. And if it's inside the cell's using it for food. That's what we want. That's what you and I want, and if you're not diabetic, then that's exactly what happens. Okay? So our cells will take glucose from our blood, take it in, and then it will use it to create ATP. That's what we want to happen. If you are diabetic, your cells don't do that. Your cells are here, your glucose is here, and the glucose can't get in. So the cell says, I'm hungry. And it sends that message back to your brain. And so what do? You eat more. And it increases your blood glucose. And when your blood glucose levels get too high, it can cause you to die. The difference between the two is insulin. Insulin is a hormone that tells your cells, hey, dinner's here. When insulin is released after you eat, it's like ringing that dinner bell and saying, hey, glucose is here. So all of your cells, they open up. They open up all these proteins and allow the glucose in. If you're diabetic, there's no dinner bell ring. So these cells don't know there's food to be had, and that food stays outside. So those cells starve. When you are diabetic and you're insulin-dependent diabetic, that means that you inject yourself with insulin. As soon as you inject yourself with insulin, what does it tell your cells? Hey, dinner's ready, and it takes all that sugar out of your blood. The goal is that your blood sugar is homeostatic. Right after you eat, it increases, then it decreases after you've eaten after a while. Then you eat, but it should never get really, really high or really, really low. Both of those are lethal. Okay, so I'm going to go back to the slide where it describes insulin. It says that it's a regulator of metabolism. It's made by the pancreas, and it binds to the cell surface receptors and tells them to allow glucose into the cell. That's what insulin is supposed to do. It tells your cells, open up, let that glucose in. This is the words that I just used to describe that diagram written out. So during the absorptive state, what have you just done if you're an absorptive? You just ate. So what's your blood glucose look like? High. Everything's good. What if you're not going to use that glucose? Where does it go? To where? To the liver. And where we put a bunch of glucose together and we make it into glycogen and we put it in our liver. Okay? So all things are good. It goes from the blood, insulin's released, it tells it to go into the cells. Post-absorptive, what are you doing or what haven't you done? You've not eaten in a little while, so what's happening to your blood glucose levels? They're going low. So what's the first thing that your body's going to do if your glucose levels are low? Break down glycogen, number one. So that's glycogenolysis. Glycogenolysis is first. Okay? After we've gone through that, or if we can't do that, then what does it do? And what do we call that when we make? Gluconeogenesis. Gluconeogenesis. Yes. Okay, yes. Okay, this flow chart shows you, this is what we just said on the previous slide. This is for absorptive. This is for post-absorptive. All right, homeostatic imbalances. Heartburn is not technically heartburn, which is why it's in this digestive section. Heartburn is that there's too much in your stomach and it's pushing back up on your esophagus. So why do people say my heart's burning? Right, your heart's here, your esophagus is directly behind it or posterior to it. So it makes it feel like it's your heart, and people grab their chest. Heartburn can be for a lot of different reasons. It may be that you ate something very spicy, or certain foods may give you heartburn, fried foods, spicy foods. It could be that you're a large person, and so you've eaten a lot, and it's pushing up, and it's hitting your esophagus, and that acid's going back and forth. It could be that you're pregnant. Unless you're a boy, you're not pregnant. But once your uterus gets big, it's growing the whole time, but it gets bigger, it starts to push up on your stomach, and then your stomach pushes up on your esophagus, and that can cause heartburn. It's not uncommon for women to be like 5, 6, 7 months, 8 months pregnant and complain of heartburn, and they've never had it before. Some women even think they're dying. You're like, I don't know, because they've never had heartburn before. So there's a lot of things that can cause heartburn, and ultimately it's not your heart, which is why never mind. Take antacids. Ulcers. Ulcers are where the mucosal lining of your digestive system has been compromised. Meaning what protects you from the acids is not there. So when the acid touches your delicate tissue, what does that feel like to you? It hurts. It causes you pain. So you normally take some type of antacid because acid is causing the pain. You take an antacid to stop that pain. It works for a little while, then it starts to burn again. What do? Take another antacid. So what I'm trying to say is, by taking the antacids, are you actually fixing anything? No. Depending on what's causing that ulcer, and we teach this in anatomy all the time, the ulcer, the cause of the ulcer is your primary problem. The pain that you're feeling is a secondary problem. So you can treat secondary problems, but if you never fix the primary problem, you're always going to have that secondary problem. Well, this isn't always the case, but we did at one point think that ulcers were only caused by stress. We did find out, and it mentions, there's an experiment that is explained after this, that there's actually bacteria that gets into your stomach, and it causes you pain. Well, when it causes you pain, you take antacids, and it neutralizes that environment, and guess what that bacteria can do now? It's spread, it can adapt. It's because it's not acidic, it's not going to kill it, so it can replicate and have babies. Well, that bacteria starts to eat through the wall of your stomach. As it continues to do that, it causes you pain, so you take another antacid, neutralize it, and what does the bacteria do? It continues to replicate. Okay? So if the bacteria is causing the ulcer pain, what do we need to do? Get rid of the bacteria, and we can easily do that with an antibiotic. Okay? So when you have ulcers, there's different causes for them. But if it is one caused by that bacteria living inside of you, you need to get rid of that bacteria in order to get rid of that ulcer. Yes? Great question. The goal would be that it would be an uninhabitable environment, but the amount of pain that you would feel, yes. So you would go to the doctor, and the doctor would say, oh, okay, it's this, and then there you go. So, good question, though. This is showing you the mucosal lining and what an ulcer looks like. It eats through that protective layer. Okay, whether it's the bacteria, whatever it is. Here's a hole just showing you. The bad thing is this. If you don't treat it and you continue to do the antacids, eventually it eats through this tissue, and when your stomach acid is loose in your peritoneal cavity, it can kill you. And there was a gentleman this summer, big, tall, healthy, athletic dude, had a stomach ulcer, and it ruptured. It went through his stomach lining. His gastric juices went into his cavity, and he was on life support. And they were able to figure out what it was, and he spent a few days in ICU, and then a week or two in the hospital, and he was able to go home. But it was that fast. Like, as soon as it started leaking, it was a bad situation.
You said 2005?
Is when they barely figured that out. Yes, I know. Okay, and this just talks about that study. So that's the end of this. Yes, sir.
What if we've been having back in before all this fun stuff?
Okay, so antacids have, before there was like formal Tums, they would take just baking soda. Anything alkaline.
Well, I'm talking about like what is your body naturally do to fight that way? Does it do anything, or is it just like rest around?
And the acids are there for that. But there, if you can't get rid of the bacteria, and if the bacteria has adapted.
How can stress cause ulcers?
So when stress causes ulcers,